Maturity of cotton using polarized light. Take a close look at this ordinary beam of light and note that it vibrates in several planes perpendicular to its direction of propagation, as indicated by the multi-directional arrows. So this beam of light appears cylindrical in shape. If plain transparent glass is brought into its path, see that the light is transmitted completely without any visible change. If instead of plain glass we now introduce a polarizer, note that the emerging light is vibrating in a plane parallel to the direction of orientation of the polarizer. This is called polarized light, and as you can see for yourself, its intensity is obviously less than unpolarized light. Now if an analyzer is also introduced as shown, notice that it allows the polarized light to pass through unchanged, so long as it is oriented parallel to the polarizer. This is called the parallel position in a polarizing microscope. If the analyzer is rotated so that it is oriented perpendicular to the polarizer, note that no light emerges from it and we now have a dark field. This arrangement is known as crossed polars in the microscope. Now take a look at this arrangement. The light source is at the bottom, the polarizer is above it, and the analyzer is uppermost. This is exactly the optical arrangement in a polarizing microscope. Now here is the polarizing microscope. Note its main parts, namely the light source, the polarizer, the stage to place a glass slide with fiber specimen, the objective, the analyzer, and finally the binocular eyepiece. All of these components except the light source can be rotated to any desired position. Now here is a view of a fiber in polarized light as seen through the eyepiece. PP- shows the direction of orientation of the polarizer. Note the fiber appearing as it would in a simple microscope. Here is a view of the same fiber with the analyzer oriented parallel to the polarizer. AA- represents the direction of the analyzer. There is no significant change in the appearance of the fiber. Now let us rotate the analyzer to have a crossed polars view. Notice that the fiber is now invisible. Now rotate the stage of the microscope so that the fiber is at 45 degrees to PP- or AA-. Notice that the fiber begins to become visible, and at 45 degrees it is brightly colored due to the interference effect. Note also that there are two perpendicular extinction positions and two perpendicular positions of bright fiber when the fiber is rotated. Lastly, take a good look at how this principle is used to differentiate between mature cotton fiber, half mature cotton fiber, and immature cotton fiber.